Oh, fudge.
I don't have all this because I'm in Mr. What's his name?
Miss Russell, can I look something up real quick?
Yeah.
It'll take like 5 minutes. No, it won't take 5 minutes. It'll take like a minute.
Just hold that thought.
You
I'll
can
let you look at it. Okay, guys, this is your factoring guide. If you remember, we've got a test scheduled for Wednesday. It's open notes. So this is notes. So if you, I keep this in, keep up with this, and that way you'll have it. There's some special cases. You know how when we first started factoring those 3 terms, we'd make the boxes?
Yes.
And that works good if it's not a special case. But like, for instance, difference of 2 squares, which I call it a dots, difference of 2 squares, it's a special case and it's super easy to factor. Like if you have a squared minus b squared, to factor it, all you have to do is a plus b, a minus b. And let me give you an example of that. And if you're wondering to yourself what the squares are, maybe I should write that in blue. Anybody know what a perfect square is?
4.
4 is a perfect square. Let's start. 1's also a perfect square. 9, 16, 25, 36. If I know I'm going to be doing some factoring, I like to have the perfect squares kind of fresh in my mind. So, what if I ask you to factor x squared minus 9? You hopefully will see, do what? Yes. Hopefully you'll see that it's a difference of 2 squares, because I can write them both. Okay. And now, I also like to go ahead and just write them underneath, because that's going to make my rest of my job super easy, because I'm going to put 1x here, a 3 and a 3, and according to my pattern, it's a plus and a minus. That will work for any difference of squares. And I looked, talking about always checking for a GCF first. I looked and we didn't have one, so I felt, it's okay to move on. If you want to flip it over or somewhere on your paper, let me give you another example. I'm going to write it in green. 16x to the 4 minus 25. Is that a difference of 2 squares?
Yes.
Sure. If you can write them, if you can break them up and write them as 2 equal products, it's a difference of 2 squares. And I like to go ahead and do that, because then when I come down here, I've already got what I need for my parentheses. I'll also go ahead and do the signs as well. So that's just a pattern. And when you run across that difference of 2 squares pattern, that's how you factor it. Sum of cubes. Sum of cubes has a pattern. Let's talk about what we think the cubes are before we move on, though. What's 1 cubed? 3. What's 2 cubes?
2. No.
3.
No.
Wait, cubed sounds very right.
Itself times 3.
27.
So 3 cubed will be 3 times 3 times 3. 4 cubed would be 4 times 4 times 4. 5 cubed will be 125. 6 cubed will be 216, and so forth. So that's another thing. If I know I'm going to be working with cubes, kind of have those fresh in your mind. Yeah. That's all I know pretty much off the top. 749 times. Alright, so let's look at the pattern for this one. The pattern for this, it's a little bit different maybe than what you're used to, but this is the pattern for a sum of cubes. You take the a plus b, a squared minus ab plus b squared. And the way I remember it, if it's a plus, it's a plus in the first parentheses, then the alternate. Plus minus plus, and that first set of parentheses follows whatever's given, so if it's the sum, it's the sum. But you'll have to come to your own, whatever helps you to remember it. So let's look at a real example. X cubed plus 27. Is that a sum of cubes?
Yes.
Okay, how would we write that?
Exponent something.
Okay, and then
300.
right. So our A is we could say X, and our B is a plain old 3. So according to my parentheses, I write X plus 3 here. Open up another parentheses. I square the first term. This tells me to take one of each and multiply. And this tells me to square the last term. And that's just a pattern, and it just works. And remember, we're always looking to see if there's a greatest common factor. There wasn't one. I know you probably don't have room, but I'm gonna give you. Okay.
Put it on the back.
Yeah, that's what I did. This is a sum of cubes. If we were gonna break it up, it'd be 6x times 6x times 6x. Is that piece? I hope that piece is okay. Alright, if we were gonna break up 125y cubed, it'd be 5y and 5y and 5y. As long as you can write them as the 3 and they're the same, then you know it's a cube. The pattern says to do 6x plus 5y. The pattern also tells me to square this first term. We're alternating signs. You take those and multiply them together, and then square the last term.
And then is there any another thing like this?
No, that's it. For the box term. These that are kind of special cases are very easy to fact. They just are. Difference of cubes. It's same sort of situation, but the pattern changes just a little bit. Instead of this first being A plus B, remember I said that first parentheses always follows the sign of what's given. And instead of the two signs alternating, in the second parentheses, they're both going to be plus. So, as far as the pattern, all that changes is the signs.
Well, they were switched.
Yeah. I always can get started by knowing if this is a plus, that needs to be a plus. If that's a minus, that needs to be a minus. And then I've memorized that these alternate, and then these are both pluses, which is pretty easy. Okay, let's try this one. 27x cubed minus 8. Are we comfortable with that being a difference of 2 cubes?
Yes.
Because it's 3x, and then the 8 is the same as 2 times 2 times 2.
Why is it 27x cubed and not? Why is it 27x cubed and not minus 8 and y cubed?
Because it doesn't have to be. It could be. That's just not the example. It's just not. It could be. As long as that variable is cubed, it will be a difference of cubes. If that was minus 8y squared, then this is not a special case because they both have to be perfect cubes.
I meant, did I say x squared? I meant x cubed.
Well, you did, and I'm just saying, just because we didn't choose to in this problem, you could work that example and it would be. Just did. Okay, so this one, it's gonna be 3x minus 2. I'll put my second parentheses down here. Remember, you square the first term, multiply, square the last term. Special cases. It actually, it should be, no, that's right. Okay, so let's look at this one. What's the first step in factoring, according to your paper? Look at the very top of your paper.
Find the greatest common factor.
Does this one have one?
Yes.
Say 3. And I just divided everything by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. 60, of course I'm following up. I dropped my sign down, and 60 divided by 3 is 20. Now I'm in business. I've done that first step. Now, where you go from here is really up to you. You like the box method, use the box method. If you don't. What you're trying to decide are what two numbers can you multiply and get negative 20 and add and get 1. So it's going to work. What two numbers can you multiply and get negative 20? So tell me something.
4 and 5.
2 and 10, 1 and 20, 4 and 5. Will any of those combinations give you a 1?
4 and 5.
Only 4 and 5. And if I want to end up with a positive 1, which is what they're telling me I need, which one of these needs to be positive and which one needs to be negative? And now that satisfies everything. That is what you're doing when you use the box method. When the leading coefficient is 1. Now, if the leading coefficient is not 1, you probably need to use the box method. Because it'll eliminate all that trial and error. So let's just look at one like that. 2x squared plus 15x minus 77. Common factor? No. Okay, so, this one's gonna be fun. Let's try something. Are y'all okay with where I got 2x and x?
No.
Because what goes here and here has to give me that first term. And 2's prime, 2 and 1, that's the only combination that'll give me 2. Okay. And you can use the box method for this. You're going to get a real big number. That negative 144 is going to be a little bit difficult to work with. What can go here and give me negative 77? 11 and 7. And 77 is prime. So it's either 1 and 77 or 11 and 7. Now, the only thing we don't know is about signs. Because if this is a negative and that's a positive, then they're going to be different. One's going to be a plus and one's going to be a minus. How do you know where to put the plus and how do you know where to put the minus? The short answer is you don't. You take a guess and see if it works. And if it doesn't work, switch them. How do you see if it works?
Work it out.
You pull it out. Yeah. Take a guess. Which one do you think should be positive?
Plus 11.
That's right. because getting this period cut short, I would have spent a little more time on that, but I don't, not to get through these four examples. Okay, so factoring by grouping. Everything that we've looked at has been 2 or 3 terms, right? Do you know what to do when you see a 4 term? Right?
I was gonna say you could combine like those together.
So, here's what I'm gonna ask you to do, okay? When you see something like this is gonna be the thing that you do for 4 terms.
Like, can you separate the
You,
last half of it and put it together there?
and that's exactly what we're gonna do. We're gonna look at these as 2 separate parts, okay? And we're gonna find the GCF of each part. Okay, so if you're looking at that first thing I have underlined, what's the greatest common factor between those 2 terms?
One. Well, x squared.
X squared, right? Okay. So x cubed divided by x squared is x. X minus 2. Okay, I'm going to drop my plus sign down. What's the greatest common factor between these? Okay, now stand back. If you've done it correctly, you should have identical factors. Do you see 2 identical factors?
-2. Well,
X minus 2. Your answer is you're done for the box rule.
Wait. Oh, yeah, I see how it works.
Because when you get to this last step, what you're actually doing is factoring out an x minus 2 because it's common to both terms. So, whether you know that or not, you'll probably be okay. I want you to try this one. Oh no, we're going to do it together because it has a minus sign and you won't know what to do with the minus sign. Okay, write this one down. If you have to write it on the back, please. I'm going to remind myself that I take these 2 at a time. What do we think is the greatest common factor of that first step?
X squared.
Beautiful. Y'all okay with that factoring out the x plus 1? Drop your minus sign down. Now guys, tricky alert, okay? If you've got a minus right here, go ahead and put your parentheses. When you factor out a negative, what's going to happen to that minus sign?
Probably positive.
Okay, just don't forget that. It only happens when that very little sign is negative. Otherwise, you don't have to worry about that. Okay, what's common to both of these?
Oh, whoops.
9.
Sorry. I worked it.
9, right? 9 will go into both. So if I divide both of these by 9, you get an x and a 1. Step back. And hopefully you see 2 common factors. X plus 1. I'm going to factor out an x plus 1. I factor out an x plus 1 here. It leaves me x squared minus 9. What time is 1:45, right, guys? Okay. So please keep that. And do you want to give the sheet back so you don't have to keep up, or is that the only one I gave? Okay, I was going to give you some to practice on. Okay, good job. Thank y'all.
I'm just trying to.
Bye, dear.